Okay, my friends, let us get going. So, again, lessons 11 and 12, we are talking about how multiplication and division are related or connected. And then in lesson 12, we were being introduced to multiplication and division facts and going a little deeper with them. So let us go ahead and just kind of get our brains moving back into math and multiplication and division. So remember, we did talk about what multiplication actually is. So when we multiply, we are adding together equal groups to find that product, that total. When we talk about the inverse operation of division, we are talking about taking that total, taking a known total, and splitting it up. Dividing it, partitioning it, fractioning it. You're going to, again, hear it in many different ways. It is important that you learn the synonyms for division or the root word divide and how that could potentially appear in a word problem or on a test or in a textbook or on a worksheet or on a computer program or wherever you work on multiplication and division. All right. And then as we were working through the inverse operation and the connectedness between multiplication and division, and as we were working through these facts, you were seeing that we were taking three numbers and manipulating them, making multiplication sentences, making division sentences, where the numbers weren't changing. So we would have a factor and a factor and a product for multiplication. We would have a dividend, a divisor, and a quotient for division. And then you quickly saw yesterday how what we were really doing was working with fact families. Fact families. And we were taking those same three numbers and we were creating two multiplication sentences. And we were talking about the commutative property of the factors. And then we were making two division sentences where the equal groupings, the number of equal groups would change. But the numbers that you were working with stayed the same. We're going to keep on going with that a little bit before we start our quiz for 11 and 12 in a few minutes. So I'm going to share my screen in a minute. We are going to talk about page 255. It has money on it. Money, nickels. So please make sure you have that in front of you, and I'm going to go ahead and share my screen, and we're going to work through that question on page 255. So give me just 1 second. All right, friends. So on page 255, we're going to talk a little bit about Jo and her nickels. So here we go. Jo knows nickels are worth 5 cents, and she needs 40 cents altogether. She wants to find out how many nickels she needs. So Jo writes this division sentence. 40 divided by 5 equals, and again, that square is the unknown. How many nickels does Jo need? Now, friends, there are a couple of ways that you could model this. Remember, we talk a lot about modeling and we talk a lot about the whys in math. We could do, for example, this 40 divided by 5 division sentence, and we could apply what we call the standard algorithm to it, but that doesn't tell us why. We're about the why. We need to show our work or model our work, and that's what we're going to do right now. So Jo wants to know how many nickels she needs for 40 cents. Now, if we take our multiplication facts, that's one way we could approach it. So, for example, we could say 1 nickel, or 5 times 1, equals 5. Okay, that's 5 cents. Or
if there's anything I haven't started
you can
yet.
say 5 times 2 is 10 cents, or 2 nickels is 10 cents. I could say 1 nickel 3 times is 15 cents. Friends, as a reminder, you need to stay muted. Please, everyone, check your mics. Thank you. And we can keep going. 1 nickel 4 times is going to be 20 cents. And we just keep on going. 5 nickels is 25 cents. 6 nickels is 30 cents. 7 nickels is 35 cents. And 8 nickels is 40. And can I stop? Yes, I can. Because I now have the 40 cents that I needed. Now, friends, can we go to the next step? We absolutely can. Because now what we can do is build our fact family. Because we have everything we need to do so. All right, so we're going to start with that 5 times 8, or 8 nickels. And we know that that is 40, or 40 cents, right? And we can also use that commutative property. And we can say 8 times 5 is also 40. And then with division, we can start with the 40 cents and split it up. And we could say 40 divided by 8 is 5. We could also say the 40 divided by 5 equals 8. Again, friends, this is our fact family. This is our fact family. Notice what is not changing. The numbers being used. 5, 8, and 40. That is what is not changing. Okay? I'll give you just a minute to make sure you have that written down. There is another way that we could approach this. I do want to show this to you as well. Remember, there are many, many ways that we can model. So we could also do this. We know that Joe needs 40 cents. So we could say, okay, I'm going to start with 1 nickel, 5 cents. That's a nickel. And then forward counting, right, or skip counting by 5s, that's 2 nickels. 15, that's 3 nickels. 20, that's 4 nickels. Everyone see what I'm doing here? 25, that's 5 nickels. 30, that's 6 nickels. 35, that's 7 nickels. Oh, I'm sorry, friends, it looks like my screen froze a little bit. Sorry, friends, my screen froze there for just a minute. So continuing on, 35 cents, that's 7 nickels, and 40 cents, that's 8 nickels. All right? Notice how we are coming to the same conclusion, just a different way to model it. Okay,